using Oracle Enterprise Manager for enterprise monitoring. This webinar is brought to you by Datavail. Today's speakers are John Coughlin, Chester Sitkowski, and Patrick Gates. Patrick Gates' background includes 15 years experience specializing in database architecture, DBA performance tuning, and managing the infrastructure for enterprise database operations of over 300 databases. Patrick has designed and developed comprehensive database administration solutions for high performance, reliability, and integrity, including backup and recovery and fault-tolerant connectivity. John has more than 20 years experience in the IT industry, including more than 12 years as an Oracle EBS database administrator at Level 3 Communications and at Oracle Corporation. His specialties include implementations, upgrades, performance tuning, and extensive capability to support the product. Chet has an excess of 25 years of experience in the IT industry, including more than 10 years in IT technical management. Chet's areas of expertise include large-scale data mining and reporting systems, as well as database, systems, and applications architecture. His extensive knowledge of systems, automation, and process tuning across a variety of platforms provides unique perspective as applied to Oracle database and Oracle applications environments. Chet leverages these unique analytical skills and his project management approach for Datavail's largest customers to offer focused, customer-specific solutions to Oracle eBusiness Suite's most complex problems, including Oracle systems performance. Before we begin, I would like to remind the audience to please feel free to submit questions throughout the event via the question chat box on your webinar toolbar. Our speakers will stop when they can during the presentation, and we will also leave some time at the very end. I would also like to let the audience know about a special that Datavail is offering to today's webinar participants. 10 random attendees will be chosen to receive a one-month review of their alert history by Datavail's Alert Optimizer tool, which will be discussed today. Participants will need to go to http://info.datavail.com/OEM offer to be entered to win. And now I would like to turn the call over to today's presenters. Please go ahead, gentlemen.
Thank you for the wonderful introduction, Rachel. Today, first of all, we'd like to thank everyone for taking time out of your busy day to join us and talk through our OEM presentation. We're going to discuss implementing OEM, how we set up different templates to create meaningful, actionable alerts, and how we have developed the Alert Optimizer tool to help us maintain and manage OEM alert volumes. My name is Patrick Gates, and I'm the Oracle Practice Lead at Datavail, and I'll walk you through implementing OEM out of the box. Next, John Coughlin, our Oracle EBS Practice Lead, will walk you through OEM templates, thresholds, metrics, and policies. Finally, Chet Sitkowski, the developer of our Alert Optimizer tool, will wrap everything up by taking us through how to maintain OEM with our Alert Optimizer tool and walking you through a customer example where we use the Alert Optimizer each and every week to improve the information coming out of OEM to help us control our alert volumes. So, why do we use OEM? To monitor our Oracle databases, database servers, application servers, storage, etc. Well, the biggest reason is OEM is an Oracle-developed product, and what better tool to monitor an Oracle database or Oracle WebLogic middle-tier server than an Oracle-developed tool. Today, IT organizations are coping with more and more complexity than ever before. We're facing issues ranging from growing data volumes to composite applications to visualization and how to best utilize the cloud. Managing all these systems and services 24/7 is a giant challenge and a constant battle before IT. Oracle Enterprise Manager provides us an integrated console that gives IT departments business visibility and comprehensive IT management across the stack. In short, it integrates IT management with business applications and systems. This integration enables us to gain unobstructed views of business transaction and the business user experience. As a result, IT professionals can focus their efforts on where they will have the greatest positive impact to the business. OEM also allows for the detection of situations which might have a negative impact on overall system performance and allows these situations to be corrected before the impact can cause the user community to be exposed to a system performance event. The OEM management agents are installed on our target hosts. whether that's a server, a database, EMC storage array. There's many different targets within OEM. The Oracle Management Server then automatically detects and configures the management agents and discovers the various targets, whether that is a host, a database, OC4Js, or web servers that are running on any particular host for which the agent itself is running. Using these configured agents, the management server is configured via its administrative web interface to collect various metrics from hosts, web servers, and you can also use the optional Oracle EBS plugin to help find parameters within the EBS architecture itself. For unconfigured agents, for all agent metrics, key performance thresholds can be set so that an alert is generated when the current value is monitored for that metric. OEM Grid provides detailed information on the current status of configured targets. The status of the configured alerts for various targets and target types are also cleanly summarized in a dashboard view that you can see on the bottom half of the screen here. This lets us see if there's any issues present that we need to look at. As you look through the stack there, the columns, you can see that for this particular, we could see all the targets associated with this host. So, and you can see everything gives you the red, green light view. So in that third column, you can see all green arrows pointing up that everything is up and running. The next column over is the alerts. So we can see if we have any active alerts for these targets. And we can also see our policy violations for each target there. And it also gives us a red light, green light view of our total disk I/O, memory utilization, as well as CPU utilization on this particular dashboard. You know, this dashboard is important because it allows these groups of targets to be associated, together as systems to collectively show the health of an overall environment as well as its lower level counterparts. As you can see here, you're quickly able to see the red light, green light status along with alerts generated. As many of you know, just turning on OEM out of the box can very quickly overwhelm you with the number of alert notifications, especially if you have hundreds or thousands of targets in your environment. Using these notifications in conjunction with the ticketing system allows for a seamless end-to-end tracking of any performance event for historical analysis of the response time to an event, the detailed analysis performed, and the remedies which were ultimately actioned by the DBA team. Many times, OEM is not implemented in conjunction with the ticketing system to track all alerts that a DBA or DBA team are addressing. One of the benefits of our Alert Optimizer tool is the ability to visually show how many alerts or notifications are coming from your OEM system. If the OEM notifications are only going to a DBA's mailbox or a mailbox monitored by a DBA team, no one else gets visibility to these alert volumetrics that are being generated by OEM. The history with the OEM repository, within the repository, is what allowed us to develop our Alert Optimizer for our customers. This alert history allowed us to develop the trends over many different timelines and allows us to pinpoint where the noise is coming from in relation to targets, metrics, and policies. Now John's going to come in and walk you through what we have done to customize OEM templates.
Yep. Hello, everyone. This is John Coughlin. I'm the EBS practice lead here at Datavail, and I'm just going to give a review on the OEM templates and kind of how we use them. Many times, OEM Grid is implemented out of the box with very little customization to the templates. This can lead to the boy that cried wolf situation because of the copious generation of non-actionable alerts. Many DBAs may ask, what's the advantage of creating templates? Monitoring templates simplify the task of standardizing monitoring settings across your enterprise by allowing you to specify the monitoring settings once, and then you apply them to your monitored targets. This makes it easy for you to apply specific monitoring settings to specific classes of targets throughout your enterprise. For example, you can define one monitoring template for for test databases and another monitoring template for production databases. Across our customer base, we have customized templates to align with our customers' business needs. We have created templates to align with several different customer environment configurations, like templates for production and non-production, templates that cover an entire environment, including production, staging, QA, testing, development. Also, we have templates for different database usage, like data warehouse and OLTP. Taking the time to create separate templates allows you to have customized thresholds and metrics for an environment or application. Not all systems are created equally and should not be monitored the same. Space thresholds that trigger 90% in an OLTP system are usually not adequate for data warehouse. An alert that pops 90% used in data warehouse could be a non-actionable alert because several terabytes of free space could still be available. Out-of-the-box templates may have thresholds, metrics, or policies that are set at levels that are too narrow or are too wide. Customizing templates across our customer base has given us a unique insight to what we should include in our templates. Much of the time, we disable many of the metrics and policies to get us down to monitoring the basics that are critical to supporting an Oracle database, for instance. Some of the basics that we encourage our customers to look at are, say, alert logs, database up, down, ASM up, down, listener up, down, cluster component status, file system space, table space, archive destination usage, As mentioned earlier, some of the metric thresholds come predefined out of the box. While these values are acceptable for most monitoring conditions, your environment may require that you customize threshold values to accurately reflect the operational norms of your environment. Setting accurate threshold values, however, may be more challenging for certain categories of metrics such as performance metrics. Monitoring session wait events and response time events can generate hundreds to thousands of non-actionable alerts. For example, what are appropriate warnings and critical thresholds for response time per transaction? For such metrics, it might make more sense to be alerted when monitored values for performance metrics deviates from normal behaviors, so taking a baseline. Enterprise Manager provides features to enable you to capture normal performance behavior for target and determine thresholds that are deviations from your performance norms. Chet will show you this later in his portion of the presentation. This is where we really find the Alert Optimizer, to identify these alerts and where they're coming from. User-defined metrics allows you to extend the reach of Enterprise Manager's monitoring to conditions specific to particular environments via custom scripts or SQL queries and function calls. Once a user-defined metric is defined, it will be monitored, aggregated in the repository, and can trigger alerts like any other metric in the Enterprise Manager. These are two types of user-defined metrics: operating system and SQL. Operating system, OS, user-defined metrics. They're accessed from host target home pages. These are user-defined metrics. They allow you to implement custom monitoring functions via OS scripts. Whereas the SQL user-defined metrics, they're accessed from the database target home pages. These are user-defined metrics that allow you to implement custom database monitoring using SQL queries or function calls. I'm going to go ahead and turn this over to Chet so he can perform his portion of the presentation.
Thanks, John. Thanks, Patrick. Greetings, everyone. My name is Chet Zitkowski, and I'm the Service Director for Enterprise Accounts with Datavail. As Patrick and John have mentioned, let's assume that across your enterprise you've rolled out the Oracle Enterprise Manager. And let's assume also that you've potentially created templates and roll those templates out to the targets. So you have OEM up and technically operational. what do you do to keep it working efficiently? As you guys probably know, having rolled out in many of your situations OEM across your enterprise, you cannot just release it and have it continue to run perfectly if specific alerts for targets are not exactly and properly configured. What we generally find, especially across the larger enterprises, is that a great amount of detail needs to be focused, especially with a large number of targets, on exactly how precisely and effectively you've tuned specific metrics for any one of the various amount of targets that you may have deployed. One of the biggest problems, as the guys have mentioned, is that across, certainly, again, a larger enterprise, not that this excludes any smaller establishment, is that you are generally overwhelmed with the number of alerts from a non-optimized metric setting within Oracle Enterprise Manager. This might cause you to become overwhelmed. So again, given this volume of alerts that are probably coming your way, in some of our largest organizations, we could see several thousand incoming alerts generated from OEM per week. So the situation becomes, how can you take that larger data volume of alerts? Previous screen, please. Okay, so given the large amount of alerts that come in potentially from across an enterprise, how can you possibly, as it's not possible in the native OEM Grid tool, to collectively show the alert volume that comes from OEM? As we're tasked with several of our largest customers with a monitoring service which primarily relies on the use of the OEM Grid tool across, for many of them, thousands of individual targets and 30 to 40 individual systems which are composed of those thousands of targets. We had no effective way to basically manage that larger volume, and we were always basically in the weeds trying to deal with individual alerts that are coming in those huge volumes. So what we decided to do was effectively take a 10,000-foot view of the overall incoming alert volume. So therefore, we began to basically probe the OEM repository for the alert history. And from the repository, we were able to take a data analytics approach towards assembling those thousands of alerts for several of our larger customers and aggregate them in a form that made the most sense to effectively begin to address the root causes of that larger volume of alerts. So what you guys see now on your screen is just a sample set of that data for the OEM alerts produced for, let's say, a demonstration customer. The first grouping that we found most effective was to group the total amount of alerts that come out of OEM on a 7-day calendar basis. So the bucket size as presented on this demonstration screen of the OEM Alert Optimizer tool shows 30 days of alert data, each grouped by what breaks down to, in this case, just over 4 calendar weeks. So you can see on the first week, 1402, meaning that it's the second week of the calendar year 2014, which spans from January 12th, 2014 to January 18th, 2014. You can see collectively across several systems, as I'm clicking through here, as you know, you can group targets into groups and systems. In this case, the Alert Optimizer tool automatically and recursively groups a specific alert associated with a metric for a target. It reverse walks up the stack, similar to a bill of materials, just like the hierarchy represented in the OEM Grid tool. It walks it back up to a system. So the container displayed in what is essentially a pivot table is shown in this XY representation of groupings of alerts. So clearly you can see in the first calendar week for the 30-day alert sample taken from the repository using the uniquely assembled alert history data, there were 704 alerts on the first week, 662, so on and so forth. This last week, for example, is not a complete week. However, using the pivot functionality, you can easily filter out any number of weeks, any specific time range, all of the functionality that comes across in any standard pivot table and associated charts, as you can see at the topmost portion of the screen, is available for you to slice and dice at your leisure your alert history volume so that you can eventually drill down into the root cause and hopefully the potential solution towards your most problem children, your worst offenders. Also from this screen, you can see that, again, using standard pivot table and chart functionality, the collective group is sorted by color. The intent there, green being the lowest numbers, and it's all ratiometrically calculated by the Excel pivot table itself. Green are the least problematic target alert volumes. Red, as you can see here, 300 alerts for one system in one 7-day calendar week, shows that that might be an area you may choose to focus your attention on. The idea being that the visual representation is the quickest and easiest way to look through what essentially are thousands of rows of data. Again, using standard functionality in the pivot table, this is the base data set that comes from the Oracle repository. So you can see clearly that this amount of data, which is similar but not identical to how it might be represented within the OEM Grid tools front end itself, there's no way to collectively aggregate that type of data into a visual representation that you see here. And this is where the power of the Oracle Alert Optimizer comes into play. So again, building on the standard pivot table functionality that's available here with the underlying data set as represented by your alert history, you can then, for any specific week, then use the functionality to drill down individually, again, using the parent-child hierarchical relationship available from the repository itself. You can drill into a specific, in this case, metric name. So if you hover over that particular metric name, you can see that the highest offender across the board for that particular week, and this can be done easily for any one or more weeks. As your screen slowly updates, you can probably see that. But again, this functionality is totally tailorable. You can, within this pivot table and chart, totally change the hierarchy, as the pivot table functionality within Excel allows you to do that at will. Generally, what we found for our largest customers where we use this specific tool to meet weekly to, as a team, an applications DBA support team for our customers, address the root cause of largest volume offenders for targets. This has been probably the most productive specific hierarchy, and again, this is all tailorable depending on the customer's request. And the beauty of this tool is that it is, in fact, currently a spreadsheet. There's a future version that will be a web-optimized version of the same product. However, as it stands now, you will have a spreadsheet that contains the pivot cache, which contains your actual row set for your alert data, and you can do anything you want to this tool. Nothing's cast in stone. So if you're familiar with how pivot tables and pivot charts work in Excel, you will have your data set and you can analyze it however you'd like. This is merely a template to get the customer started to use in what we've generally found for most of our customers to be the most effective representation of how to assemble the hierarchy for the alert volume that comes from your OEM enterprise. The tool is also capable for those customers that have multiple instantiations of OEM Grid. For example, a customer who has 10G previous incarnation and is versioning over and up to OEM 12C. The tool is capable of probing both repositories in an exactly identical fashion, so you can actually aggregate your entire enterprise, even though your source of alert history is coming from one, two, or more OEM Enterprise Manager Grid Control instantiations, so we can collectively aggregate those. So here, again, as we drill down to the first level of hierarchy, you can see that for this particular week, and generally the weeks tend to follow the same trends, you can see for this week that blocking session count on this particular system as referenced above in the column header, was the highest volume offender. We typically find that blocking sessions and, as John had mentioned, with his reference to real-time Oracle performance database monitoring screens in Grid, if the customer has the wait session classes turned on, generally because they never chose to effectively analyze and produce a template for that particular metric name, you'll find that those two are your worst offenders. The idea being, why would you monitor them if they're producing many, many alerts, none of which, or very few of which, are actually actionable? Again, this tool pulls your attention immediately to see that that is in fact true in your environment. So again, following the same concept of drilling down from parent to child, again, similar to the hierarchy as displayed in OEM Grid, the next layer down from the week, as you hover over, you can see date range there, hovering down to the next child in the parent-child hierarchy is the metric name. Now we've just drilled down into this, these are all standard Grid concepts of the target name. So you can see for that week, for the metric of blocking session, now we have specific database names that I mentioned. And again, you can see, and these are all equally color codable with standard Oracle functionality. The reason it's just not enabled now is it becomes a little bit too visually noisy. But as you get the hang of using this tool, you can color code to your heart's content. But even here visually, you can see that in this particular week, for that blocking session count, it was in fact this database that generated 268 alerts alone. So clearly, there's your problem child. Furthermore, obviously, that is the database instance. The next child down in the hierarchy is the object type. In this case here, as I mentioned, you can have a large enterprise where you have multiple instantiations of OEM Grid. You can see the tool is able to probe for which version of the repository this came from. So for that database, if you did not already know that, you would know that this group of alerts on that calendar week came from 10G. Now, here is the actual timestamp of every single one of those alerts. And you could sort this forward, backwards, largest count to smallest count. In this case, as you guys probably know, for something like a blocking session count, they come in death by paper cut groups of one. But this is all chronologically sorted by time, as you can see here. So we'll break this back down. Easily done just by collapsing the hierarchy one by one to take you back. And all of these are equally expandable. If we take, for example, table space used metric, again, you can see that it's going to, for that metric name, drill down into the target name, which again is a database, same type of thing. This is available for all of the individual metrics, and it'll give you an accurate depiction of the chronological history. Any of these children can be made parents, and so on and so forth. It's completely flexible with how you choose to represent it. So quickly, again, drawing your focus back to the charts. The chart to the left is a standard area chart, which shows collectively, again, same bucket size, since the charts are based on the same data as the pivot table below, 1 month's data grouped by 7-day calendar weeks. You can immediately, again, get a visual representation. If the numbers and the colors aren't quite to your fancy, you can use the charts as shown above here to look for the highest peak in the area chart. And again, you can see that these colors are individually grouped by system, as the legend indicates. Again, all of this is completely flexible. None of it's locked, completely available to have the customer be able to move their data around as they see fit. Again, the data is savable, transportable in an email, because the data is completely contained outside of the OEM Grid tool. There's nothing you can do here that would affect any of the alerts, obviously, since it's just a quick select query using our unique SQL to grab the repository information for alert history that allows it to be truly represented in a visual way from the pivot table view. This next view here is what we call our skyscraper view. Again, same underlying data set, but this 3D bar chart, non-stacked in this case, can give you a quick representation of where your problem children are. In this case, the taller the skyscraper, the worse the situation is. So you can then take just random views, and you can obviously just spin this around, and you can see where your worst offenders are. And then the idea being that you can go back into Grid, look at that particular target. Again, this tool shows you the exact text string name that is represented in OEM Grid 10G through 12C, and you can even cut and paste from this spreadsheet. For example, if we went in here and you went here, if you grab this name, you can go and do a target search in any of the available grid screens and go right to that target and then begin to tweak the metric name, rather the metric setting for that target name for the metric setting that's showing you that you have a huge volume of alerts for. So that's what we call our skyscraper view. Again, immediate visual indication of where you can most effectively reduce your alert volume. And we've seen customers where this 2,851 alerts over one calendar month is somewhat small. In our larger organizations that we support, specifically for the monitoring contracted service, we've seen 15,000 alerts in 1 week. So you can imagine the economies of scale that come from being able to visually analyze in an aggregate form as presented in this tool, the Alert Optimizer tool, that type of alert volume. So moving quickly over to, again, all sharing the same 30-day data set. You may be more interested in choosing a smaller bucket size. The bucket size we looked at previously was 7 days. This is the same representation as requested by some of our customers. They wanted to see the same thing grouped by day, not an issue for the tool. We simply take the exact same data set and rearrange the same pivot table, basically, for any of you who are familiar with the pivot table functionality. That's very easily done. So basically, we grab the template from the first screen and provide our customers with another out-of-the-box template which shows overall alert volume by day. So in this representation, now you're a couple thousand feet down from the 10,000-foot weekly bucket view. You can see by day how many alerts are coming across from what systems. Here they're organized chronologically from left to right along the x-axis so that you can clearly see on this calendar day here, Tuesday in this example, January 28, 2014, you had an extreme peak. Again, here you see you can have an extreme peak. From here you can go right down to the data, and similarly, just grabbing any random date here, you can go down and again look at where that daily volume came from, and you can drill down to any level and again get the target name and go right into Grid itself. In this case, this is a host, and the alert variety was a percentage of file system space that was available, or in this case not, since that's how that metric would be set. Quickly drawing your attention here to this calendar day of February 11th of 2014. And again, this isn't simulated data. This is real data that just happens to be extracted from one of the customers that's benefited greatly from this analysis. This event, after having gone through the analysis of it, because it was visible from the tool that on this day you can see just about 500 alerts in 1 day, which is almost an unmanageable amount for any reasonably sized monitoring team. This event was associated with a network outage. So again, it was interesting to see how a simple network outage, which, as you guys probably know, would affect the entire stack, including OEM Grid itself, as OEM Grid would not be able to communicate with the target agents if the middleman LAN connectivity was not available. But again, the visual nature of being able to report down to that level for that calendar day has been proven to be immensely useful for organizations that need to get a handle on their overall alert volume and the potential causes of eliminating those alerts in the future. Continuing the theme of an reducing the bucket size of the analysis. Here in the screen, same data, we have an hour size bucket across the same 30-day time period. The intent here, again, from our perspective, since we support the monitoring task as a contracted service for many of our larger customers, we need to keep a realistic analysis of how many alerts a monitoring person managing incidents generally associated in the ticketing system with any number of alerts, as you can see, coming in. How many alerts per hour realistically can they deal with? If you look at this trend, you have a reasonable baseline, somewhere 20 or so alerts. Even that, when you think of 20 alerts per hour, that quickly comes to three alerts per minute or so, give or take. Is that a reasonable amount for somebody to recognize the alert, open the incident, go to the target, validate that the alert is in fact true, record their efforts to remediate the alert and the incident associated with it, close the incident, and then have the alert come off the screen as they've rectified the root cause of the alert. This gives you a realistic time-weighted view with an hour-size resolution, and all of this is tailorable again. It gives you a realistic view of when can somebody or how can they deal with this type of alert volume. So a couple good examples that, again, immediately visually stand out from the screener. In one case, we've had, looks like 75 or so alerts. Not a huge effort, but that is more than one alert per minute and an incident per minute. That's already at the red line. But again, here you can see in this data point right here for this diva.common target, and again, all this hover functionality is available to just let you have the mouse hover over the event, and then you can go down below and drill in as you so desire to see what the nature of that particular peak was. But here, this data point is representing 175 alerts. Similarly, we have a worse offender from that diva.common parent system. And again, this is the exact text string as it comes out of the Oracle Enterprise Manager for what you've defined as a group or system. You can see that you have over 200 alerts that have come out in a mere 60-minute, 1-hour time period. So this lets you get resolution as to how maintainable is that large volume of alerts coming from your OEM Grid instances. So moving forward quickly across the tabs available to the tool, and these again are just templates. Any of these are customizable either by Datavail or yourself to do the different grouping, hierarchy, order, sorting, filtering, and so on and so forth. Here we have a representation that shows the overall incident volume coming from Grid by volume, by the metric name, excuse me. So here again, and as we often see across our customer base, the session blocking, user blocking at the database or database instance level, you can see that by far user blocks in this example here of the underlying data set is the #1 offender. This is something that OEM Grid itself in their GUI, even in 12C, simply does not show you. The only thing you can see in Grid is when you do drill down to a target, how many alerts come over a specific time period from a specific target. There's no way in Grid 12C currently to step back and look at your enterprise as a whole and see where your alerts are coming from. So clearly, if we were tasked with helping remediate this particular situation, we would go and look at the metric for blocking sessions, which is a tough metric to tune. We're in the process of developing some custom tools where we can use a user-defined metric, as John mentioned, to custom code and remove the seeded session blocking event so that we truly only know that a session block is important when it begins to affect the wait session classes for application or concurrency in a database instance. This is a perfect example, as shown here, that might be the #1 task an organization might want to go and implement. And here you can see you would have, if you bring this down, it'll never be 0 since session blocking, even when it's real, is not something generally totally eliminatable, but at least you would have been able to tune the metric to only fire when you have a situation that requires remediation, whether it be killing a session, killing a program, making sure that a concurrent program, in the case of the e-business suite, isn't stepping on top of itself. It, for example, was not made to be incompatible with itself, or if a program should have been made compatible with another program, or if a form has record locking established, and so on and so forth. Again, the point back to the tool is that you clearly see that you need to address, in this case, user blocking type metric, resource status, and any of these other alerts that some are UDMs from the customer themselves. But as John mentioned here, you can see response time is definitely in the top 5. So as you go across from left to right, we call it the low-hanging fruit concept. You can address your largest offenders to gain back most of your application's DBA or monitoring team time from the pool to add it in a quality fashion to the collective pool of time that became yours again once you eliminate having to address these effectively useless alerts in many cases. It's really something that doesn't visually show up in the OEM Grid tool. So the last template to take everyone through quickly is the same concept, but now we've just simply changed the hierarchy to represent the volume by target name. So as opposed to the metric name in the previous tab, now we can see from left to right, grouped by overall volume of alerts over the 30 days, you can see the system name or the parent object. And again, this is totally tweakable. You can see in this case a group or system called EBS prod was your largest offender, representing 592 alerts individually. And again, in this case, we've turned color coding on, a feature that's easily implemented or not, to bring your attention, as if the graph wasn't enough, which system is your problem child. Again, this allows you to revisit OEM Grid itself, take that target name in, look at the metric name from the previous screen that's generating that, go to the actual target, and take a real-world assessment of why is that metric generating so many alerts over time. So that's the basic concept of using the Datavail Alert Optimizer tool to go through potentially thousands and thousands of rows of data, group them collectively into something that's usable to allow your applications DBA team to effectively go into the OEM Grid tool itself and basically clean house. One of the solutions, as John mentioned, would be to create templates that are usable. From using this tool, you can get a good feel over a small amount of time, is what we found, of how to properly tune a metric template. And once you figured it out for one target, again, let's preclude the concept of a baseline since all environments are not created equal. But for many of the hosts, there are generically usable templates that if you set reasonably, again, using this tool for a feedback mechanism, which is what you don't have in Grid itself, you can use the tool for a feedback mechanism to custom code a metric. And then the beauty of OEM Grid there is once you've tuned the metric, now you can roll that metric out for a particular target type, let's say. You can roll that metric out across your enterprise. And then maybe even there you've eliminated 50% or so of the alerts from that target type. You may have then the ability, again, using the tool as a constant feedback mechanism, since this data set is continually updatable, it's not static, it's live. You can go in and then further refine, even on a template for a particular target, you can further refine the metric settings to keep your alert volume down to what's considered reasonable. Again, the concept of an actionable alert as opposed to an annoyance or a nuisance alert. We found that it greatly increases the effectiveness of a monitoring team and those that are tasked with these inordinate number of alerts that we see across the board. Again, with Grid, with all of its power, if it's not properly tuned, like any fine machine, can be more of a burden than an aid in keeping your enterprise targets up, alive, and healthy, and having you aware of their true health, not their apparent health. The tough part is when you have a tool like Grid, to have it represent the nice green circle. Now, we all know we'll never have a green circle across certainly hundreds or thousands of targets. At least we've very rarely seen that. But you don't want your pie chart to be half red, half black, gray. You want it to be a large portion green, and everything that's not green, you really should know why it's not green and how you can effectively tweak your metric settings to at least have that pie chart at the highest level dashboard available in Grid tell you what the health of your overall enterprise is, which was the concept of Grid itself. It does take a lot of refinement, but the problem we found in trying to manage that for our customers for which we monitor is to have a data set that you can use for the feedback mechanism to allow you to properly tune those metrics and targets. So with that, I guess Kelly will open it up to some questions.
Great, thank you very much, Chet. We do have quite a few questions here, so let's get right to that. The first one, is this an additional feature on the database, or is it a built-in feature of the database? Patrick?
Okay.
Chet, go ahead and answer that one. That's your baby.
Okay, so I mentioned this briefly. I apologize. I was just, in the interest of time, I didn't want to go too deep into how the tool works to get its data, but this is a unique query that Datavail has produced to consume the information that's already available in the OEM repositories database, so we can properly gather the alert history from the OEM repository itself. Nothing's per se required to be installed in your OEM repositories database to effectively run this tool to get the underlying row set to represent the data as shown here.
Okay, thanks, Chet. Next question. This plays with 12C, right? Because all that they were seeing were OEM 10. So what version does it play on?
That is correct. I believe it's referenced quickly. It works and has been tested with OEM 10G, 11, and 12C. And we're happy to test any versions you may be able to throw at us. We would just need access to your repository to validate that the quality of the data is the same as it is with those 3 referenced versions.
Okay. Hi, this is a really good tool and good to see consolidated data through the charts, but we do have some of these reports automatically available in OEM report sections. Can you kind of describe the differences?
The uniqueness here is your ability to leverage the tailorability of the pivot table and filterability of the data. You can sort by any number of aggregates in the parent-child relationship. You can effectively filter out time periods using all of the standard date filtering functionality, alert fire time is before, after a certain calendar date that you may need to focus in on. There's no comparison between the tailorability of this functionality and the visual nature. Again, the tool is intended to immediately bring your attention in a really quick fashion to your most problem children. The reports in Grid are okay, but this takes it to the next level and makes it really quick to go in and focus on which are your most problematic targets. The number of sort, filter information that's available in the pivot chart is unequaled in anything that we've seen.
Okay. How do I know if we're using modified or default templates?
Well, the easiest way to answer that is if you've ever modified them. Generally, a template would, when modified, have a customized name, just so that you can look at it and know that you've modified it. John and Patrick can speak to exactly the detail from more customers where they've rolled out unique templates versus the seeded templates across an enterprise.
Yeah, you can also go to within excuse me, OEM itself and see all the targets that template is applied to, and which targets are using that template and its thresholds.
And I think the suggestion there is if you choose to use a template as a template, you probably want to give it, a customized name so that immediately from the template name, that, as Patrick mentioned, you see is applied to one or more targets. You know that that's a template rather that you've created, modified, and chosen to have applied to any range of targets. That becomes a housekeeping effort on the OEM administrator's part, right?
Okay, so, and we've had quite a few people ask for copies of the slides, which I believe, Rachel, we will be sending those out. And if you have additional questions, there's contact information in the slide as well as on your screen. If you're interested in having us look at your alerts for a month and running the tool, would be glad to do that, and we'll be picking 10 folks from the webinar to participate in that. So with that, Rachel, I'm going to turn it back over to you.
Great. Well, thank you, everyone, for that wonderful presentation. And just to clarify, the slides and a recording of this presentation will be available in our Resource Center on our website at www.ioug.org. I'd like to give a big thank you to our speakers today. What a great presentation. Before we conclude, please make a note of our upcoming webinars and past webinars by visiting www.ioug.org. And as I mentioned before, a recording from today's webinar will be available there also in our Resource Center. We'd like to give a big thank you to our speakers once again and everyone online for attending the event today. There is a survey after this webinar for you to complete, and we thank you in advance for your feedback. Thank you all again for attending, and please don't forget to register for Collaborate 14. Thank you, everyone.